Hey, welcome all. Let me make sure there's no one um, waiting to join. I'll keep an eye on that. I have feedback. Okay. All right, let's start. I had a few technical difficulties. For some reason, my background is missing as well, so that's interesting. But I wasn't able to stream from my playlist the video I set up for this, so I'm just streaming straight onto my YouTube channel. I'll try to reorganize it later so that you know that this is where you'll go if you want to rewatch this or share it. But I'll dive right in. I'm sure more people will join later. I'll try to keep an eye on that as well as the chat. I hope you can see my screen fine. Actually, if you could just let me know. This is my first time using Zoom and YouTube at the same time. Perfect. Okay, great. I will keep my eye on the chat. Most of the time, I would love to hear your feedback, any questions you have, anything like that. I'll keep an eye on that and make sure to answer them in real time. Nonetheless, let's get to it. So we're here for AI-generated design. The idea is from concept to reality, so using AI in all steps of the design process. I'll introduce myself. I'm Ammari. I'm a designer and AI researcher based here in Lisbon, Portugal. I'm actually from the US. I was educated in the US from interior design to architecture, as well as entrepreneurship. And I also worked in the US from design firms to being more interested in how it all works, getting into fabrication, working at an apprentice at a wood shop, a high-end wood shop, where I learned ancient craft and joinery, and then moved on. From there, I also had a studio space at a hammer space or at a maker space where I taught myself digital fabrication and even building 3D printers and a makeshift CNC and learning how to G code and all of that fun stuff before I finally joined a wood shop that just got a huge CNC and didn't have someone to design for it and program it. So I joined there and fell in love with being this kind of bridge between traditional craft and thinking and this more futuristic digital way of designing. And I just became obsessed with how much I could prevent harsh labor on the craftspeople, how I could just solve issues really quickly, how I could show my ideas really thoroughly. And that escalated into more and more technology using virtual reality as well, allowed me to go remote and become a sort of digital nomad, which I guess led me here to Portugal. And when I landed here, I joined the Fab Lab Lisboa, and they were super interested in the work and the research that I was doing with artificial intelligence. That kicked off several series now of teaching artificial intelligence at the Fab Lab. If you don't know what a Fab Lab is, it's a fabrication lab that originated from MIT. And the concept is that you would have this sort of like innovation research hub that you could create almost anything. The one here in Lisbon is really cool because it's supported by the city. So I'm able to give public free services while also being able to pay my rent. So that's super cool. That has led me to doing several workshops, several events, talks, festivals, installations, things like that. I'll touch on some of them as examples of my work and of using AI and virtual reality together. I have this QR code. If you do want to see more of my work on my LinkedIn, there are some images of my portfolio pieces that I won't be showing here at all. As well as if you want to connect on social media, I post quite a bit about AI. I'm a bit obsessed. And I try to share as much as possible. I really believe in democratizing education, intelligence, creativity, accessibility to the fullest. So I will also be posting in the future more on YouTube videos, instructional videos of this work. So if there is something that you are interested in hearing more about, we only have 3 hours today for what we'll cover. If there's anything that you would like me to go deeper on or explain more, maybe you can comment in the comment box and I can share more information about that either today or tomorrow or in the near future. Also, you may have gotten an email from me with more resources. If you didn't, you can sign up for the newsletter with that QR code. That newsletter will have regular emails on resources, different AI resources, virtual reality resources, computational design as well, that you can use, more events, more online events, things like that. Okay, so let's get started, shall we? Okay, so like I was saying, we're discussing AI-generated design from concept to reality. The idea here is that we can use AI in every step of the process. If it's conceptualizing the idea, refining our idea, brainstorming, or it's visualizing, communicating our ideas to other people very quickly, or it's fabricating using digital fabrication to create prototypes, or creating 3D models as well. All of these things will help us create better designs and faster. And that's one of the main things I'm really interested in. So today we'll just be covering theory. I think this is covering, yeah, let's go like that. So today we're covering theory. So I think it's super important to cover this. For example, during my Fab Lab AI workshop series, I would have 2 workshops a week for 8 weeks. In those 8 weeks, every week was a different modality of AI, whether it was text-based or image or 3D or so on. But in that first workshop of the week, of the 2 I have every week, I would cover just theory. And the idea here is that we need to really understand the societal impacts of AI and this technology, as well as like, where do we want to stand with it? What are our boundaries? I mean, we don't need to accept all things AI or virtual reality or any sort of technology. We get to pick and choose what tools we want to use, what tools we want in our toolbox. and then also understanding the ethical implications of them so that we can do it responsibly. AI is super, super powerful, and with great power comes great responsibility. I'm super optimistic about the future in the age of AI. And that's because I truly engage with it on a civic level, on a community level, and on a technical level. I'm developing the AI as I use it, and we'll talk more about that. Then tomorrow we'll get into practice. This is where I'll just show you a ton of different tools that you can use around AI, 3D, VR, spatial computing, all of these different tools that you can use to conceptualize, communicate, and maybe even fabricate your ideas pretty quickly. And then day 3 integration, we'll create a project together. So you can see the entire workflow from start to finish of how you can put these things together and create something really cool. We'll create it together. It'll be collaborative. And also I'll take on more questions. Maybe you can tell me about your projects, what you're looking for help with. Like I said, when I teach AI, it's a bunch of different modalities. This is like 1 or 2 of them combined. So there are a lot more tools, a lot more insights that I could give, and would be happy to. So we can explore that more on day 3. Okay, so today, user cases. We'll start off with user cases. And this is important, of course, so that you know how these things are being used today and how you can use them, and maybe you can spark some ideas for your own projects. And then, so that will cover AI and digital fabrication, virtual reality, augmented reality, and digital twins. I'll define and discuss all of these. And again, if you have any questions about any of that, I will answer them. So then we'll go into the mechanics. I won't go super deep. I mean, you could get a master's degree in at least 20 of these things. So I'll just go through them lightly so you understand the framework of how these things work so that you can use them in more empowered ways. If you can kind of understand how this theoretically works, then you can position yourself, prompt, and so forth a lot more powerfully. And then, so that will be an AI overview. We'll talk about large language models, diffusion models, and image capturing, which is super useful if you're in the design world. Then we'll take a break. During that break, we'll have a 15-minute break. I'll actually have a quiz that you can take optionally during those 15 minutes. There'll be sliding slides, asking different questions. It's really simple and kind of fun. And then when we get back from the 15-minute break, I'll go over answers and we can kind of evaluate where you are and where you want to improve. And then finally, we'll get into ethics after a nice little break. And we'll discuss deepfakes, the geopolitics of AI, sustainability, transparency, and the future of work. During our ethics section, will be I would like more of an open dialogue where we can debate, share ideas, things like that. Like I said, I think it's super important that we engage with AI and that we're not just like on the sidelines as it's being developed and implemented. Hopefully, you can't hear all of this construction. I set up 2 AI noise canceling apps. I hope they're working because there's a lot of construction happening here. So that is okay. So And if not, it'll just like add to the experience. We're talking about design and construction, so it kind of brings a grit of realism. Okay, so what is it? Let's just start there because we can get lost in the terminology. So AI, artificial intelligence, it mimics human thinking and actions to solve complex tasks. I would like to, for me, it's easiest to understand if I think about its oldest concept. Greek philosophers used to dream of this idea of AI actually, and they called it thinking computers. And that's it. It's just like, can we take our intelligence of some kind and put it in this, thinking machines, that's what they would call it. Thinking machines, it's a thinking computer. So in a way, so can we, kind of put our intelligence in this sort of machine and it can kind of think for us a little bit, or help us make decisions. But in reality, it creates systems for data analysis, pattern recognition, decision-making, resembling human cognition. And we'll get into how it resembles human cognition. And then virtual reality, VR, it creates immersive 3D environments for users, enhancing the visualization and experience in design projects. So this is really cool. I'll get more into the benefits later, but with VR, we can design and display our designs immersively. I think that's super helpful, super beneficial. It's like one step closer to physical prototyping, and getting that feedback. And you can design a bit more empathetically at an eye level as opposed to from the traditional aerial view, this top-down view. And of course, when you put them together, they're very powerful. So why is it important to integrate AI and VR into your work? Well, I believe it definitely bridges our vision and the technical execution of something. So now I don't have so many barriers to communicate or create my idea. I think that's super important because it democratizes design. I believe radically that everyone is creative and everyone has something to express and contribute to society, and that with AI, we can actually make this happen without the privilege of traditional education. Like this technology of me being on screen and talking to you guys from Portugal, it makes it so that you can get a sort of education, certain that maybe you wouldn't have been able to in your direct vicinity. But so I think it's also really important because I think it leads to more innovation and exploring new design possibilities. With AI, you can create dozens of concepts and ideas and visuals for your idea that you wouldn't have otherwise. Let me just add a couple more people. Oh, great. You can't hear the noise. Wow, AI is amazing. Okay, so you get to create more ideas and iterations, which is super powerful. I think more ideas, better, the more to choose from, the more to get feedback on. And of course, you can then start to personalize and adapt the design for your needs or other people's needs. this scales in a lot of really cool ways that we'll talk about. And rapid prototyping. So I can come up with an idea, use AI to create the visuals or the 3D model, and then 3D print all within 5 minutes, maybe less. I've done it in a minute. I've had an idea, I created the 3D model, I sent it to the 3D printer, and I was done. I had my prototype, and now I could take that prototype, talk to my client, and have a much deeper conversation about what they're looking for. They could start to try it on. They could see its relationship to them, the shape, the feel. It's super powerful. So you can gain deeper insights through immersive perspectives. So not just the physical prototyping, but also using virtual reality. Let's say I don't want a 3D print right now, or it's a larger scale like architecture. Well, I can immerse myself in virtual reality and experience the scale and the feel, the vibe. I can bring my client or my friends in, and they can experience it with me. We can see how we feel about it together. We can talk about it. It's super powerful. Okay. So, use cases: AI in digital fabrication, virtual reality, augmented reality, and digital twins, which is super interesting. Okay, so this first example is AI generated design from concept to fabrication. This is a client I had online that I never met in person, that I created an entire catalog for, with, like, in the end would be over 100 different design options or products for their customer base, which were these metal bathtubs that he was fabricating in Asia. And so and I was here in Portugal, and I think he was in Canada. So he was able to tell me what he wanted. I used text-based AI, ChatGPT in this case, to sort out the ideas, to really refine the concept, to brainstorm. Then I used an AI image generator, in this case Midjourney, to generate some potential ideas that I sent to him, and he told me what he liked, what he didn't like. And then I refined my prompts. I actually went back to ChatGPT to refine my prompts to generate images. Once I got to that point, I knew that this wasn't realistic. Thankfully, I have a ton of experience in interior design and fabrication, so I know this plumbing isn't going to work. I mean, all of this exposed plumbing, we would see so many pipes, it would be dangerous, it wouldn't look good. And why is there a couch here? All sorts of stuff like that. And then also knowing how he was going to get it fabricated was also super important in the design of the tub itself, right? So I took it into Photoshop. At the time, it was Photoshop beta with its new AI features, but now you can find this on all Adobe products. Where I used AI to fix those little moments that weren't realistic. I took out the couch, I added some built-in vanities because that's what the client wanted. I altered the shape to accommodate for fabrication, as well as how the base connects with the architecture. Then I used Blender. I used some AI tools to make it as well, and then exported it into AutoCAD to create the fabrication drawings, the technical drawings, and then it was fabricated. They created a mold and wrapped the metal around, and they could do this really quickly. And and we could do several different designs and different materials, of course. So yeah, so this is one example of how I could create a ton of designs. I mean, very quickly. In the matter of weeks, it was fabricated, where before this would have taken maybe months, well, more than months. It could have taken a year, right, to create a 300-page catalog of different designs. So, 3D manufacturing, like I said, you can fabricate very quickly, rapid manufacturing. Another example of creating so many designs so quickly, like with Nike, coming up with these designs specific to each shoe, specific to an athlete. Oh, it's a video. Yeah, so they designed several different shoes, each custom to a specific athlete, their needs. They used AI to generate them, and used 3D printers to fabricate them. They're very cool. They were made in weeks, as opposed to months or a year. I don't know if you've ever done, especially shoes, you have to make a ton of iterations to get it right. But with using AI technology like image capturing, where you can just scan your foot, and using AI to generate the ideas, a ton of them super quickly, so you can get feedback really quick as well. It's super powerful. Okay, and then this example is from MIT. It is a splint that you can customize. So imagine you just broke your finger. You could scan in your hand, and within minutes you would have your custom splint, and be able to 3D print it immediately. This is a very cool project. I think I have a link. Yeah. Of course, there's an ad. Okay. So the point is, there we go. You can just get a glimpse of it. I think the design is really cool too. It emulates crocheting, so it kind of connects the old craft and the future. And it's nice and flexible that you can just slide your hand in. Yeah, so very cool. Oops. Okay. And okay, so this is a project that I just did for a festival, where I also gave workshops on AI and VR. So I digitally fabricated a tower viewer, like you would see a point of view. And this festival was around regenerative futures. So I wanted to make sure that all of the materials used to fabricate the tower were actually pieces of cork that is local to Portugal, that would have been thrown away. So it was completely non-wasteful. And I was able to fabricate it using actually CNC for the head. There's also 3D printing for the hardware, and I use laser etching for there's the municipal, the city's logo on it, since this was supported by the city of Lisboa. But I was able to come up with this idea and fabricate it within 48 hours. I did this project just a couple of days before the actual festival. It was very quick and it worked. And I integrated the concepts of virtual reality headsets, like these like these DIY ones that are made of cardboard that we'll talk more about later. So the idea here is that you could kind of integrate virtual reality into our world. So when they would look through the viewer, it was at a point of view. So you would see this beautiful landscape or horizon of Lisbon. And then when you would look through it, you would see future possibilities of what Lisboa or Lisbon could look like. And I made dozens of them, even in the workshop itself, dreaming up what future Lisboa could look like. Yes. So these are more examples of AI generated worlds. These on the sides were mine that I created for Lisbon. But these worlds you can go totally 360 in, and you can generate them within seconds, max a minute. But of course, you could get much more detailed and edit and customize and alter design as you wish. Okay. And then we have AI generated video for the purpose of architecture, or like communicating your concept to the client. You can use video instead of just a photo or a rendering to kind of portray the vibe, the aesthetic, the shape. This just came out as a test for Sora, which is from OpenAI. That also created ChatGPT, of course. But yeah, and we'll talk more about tomorrow during practice, how you can turn AI-generated videos into AI-generated 3D models. So if you can create it in a video, you can create a 3D world, actually. So it's just another workflow of creating these AI-generated designs or worlds. I think this is super important. Like, even if you're not in architecture or urban planning or anything like that, or even interior design, if you're just designing products, objects, I think it's super important to also have the world, the environment there with it. I think context is everything. I didn't mention when I did study architecture, the idea was the first year was dedicated to environmental studies. So all in one building, we had architecture, interior architecture, product design, urban planning, and furniture. So the idea was it's all the same foundation of design principles, and it's all relative. So how we design a chair is related to how we design architecture, which is how we design a city, which is how I design my toothbrush. It is all related, and I think we can design better if we take that more into consideration. And VR can help us do that. So here I have an example of, I actually used this for projects, Archeo. I used it in the metaverse using the Oculus headset. And I could just throw in my model from SketchUp, AutoCAD, Revit. I mean, you can pretty much all 3D software at this point. You can import into this app, And you can edit with your hands. It's super cool. And you can be immersive. You can be inside. You can be at like the human level, or you can make yourself huge. You can invite other designers, engineers, clients. You can walk around together. You can edit as you're touring the space. Imagine you're with the client and they say, oh, actually, I would really like a window here. The building hasn't been built yet or anything. Or maybe the foundation was just built and you guys are all there with a headset. Or they don't need to be in a headset either. They can just be on their computer or phone and see what you're seeing. So a lot of options. Very cool. Mixing real and digital. Because you can have your totally digital model in this app, and then you can create these like peek throughs, like you see with creating the window. If you create a window in your design, you will see what's behind that space. So imagine you're designing physically in the space, and you're adding a window, for example. You will see what's beyond. Or you can add a 360 world to it. So you could generate with AI a 360 world, put it in the world. So as you're designing, you see the other side of where your client is located.
Megan?
Yes.
Yeah. Hi. What's the name of this app again?
Arkio, ARKIO.
Okay.
It's written right here.
Okay.
A lot of the times I have them written right here. So if you want to check that out.
Sure. Thank you.
Yeah, no problem. Okay. Let's see. Okay, so also, so we can design with mixed reality, but we can also construct this way. This is an interesting user case where they built the structure using augmented reality, where it gave them guides for where to put every single brick. So imagine you go to a construction site and you don't even need to really tell your crew what to do. They just put on the headset and it tells them 1, 2, 3, 4. Okay, let's get a little peek, of course, of what that would look like. Oh, so we have the mixed reality. Yeah, so it's a nice, guide, like a template. Very interesting. Okay. I guess we're always going to see that graphic of what you can draw up and what you can generate. But anyways, another example is drones. I think drones are very cool. Of course, with all technology, it can be very cool and it can also be very scary. But we're focused on the world we want to design and create. And in this one, drones can really help us out and prevent a lot of back-breaking labor. Like with this flying autonomous fruit picking robot, super cool, goes, flies around, picks the fruit, can calculate if it's ripe or ready, and would leave the others. This can also be used, a drone could also be used in several ways with agriculture, where it could prevent a lot of water use that is unnecessary, because it can evaluate what land actually needs watering and water accordingly without excess. Or we have building cleaning drones. This is a really hardcore one. So it can do a lot of stuff that's really dangerous for humans or difficult for humans. It can be, we can have an easier life, and if we use these tools for good. So, and of course, if you're, I believe a lot of you, your backgrounds are in architecture, you've probably seen drones for construction sites, surveying the land, recording to see how it's doing, things like that, or for LiDAR scanning, which I'll talk more about later. And then we have parametric design. You're probably familiar with as well. I'm not going to get super deep into this. This is a whole other master's degree you can get. But just this concept of using AI, using computers to generate architecture under certain parameters. So I can say the land is this big, it needs to have the sun moving from here, the sun is moving from here to here, the wind is moving from here to here. I need these pathways to get to the employees need to get to their office efficiently. There needs to be a kitchen. I can put all of these different parameters in, and even those from stakeholders or the community. Let's say this citizens have input that they want to incorporate. This can all be a place to collect that data and experiment with it. And we can use extended reality in urban planning as well. On the right here, this is a cool example of designing 15-minute cities. So it ensures that there is a park, there is so many, there's a hospital, there's transportation, education, a library, you know, restaurants and shops. There's all of these things within 15 minutes of walking, which can help ensure accessibility, and that we don't need to necessarily always use cars, and things like that. So super important and a bit complicated. But why this is interesting is you also then don't always have to design from top down. You can design immersively from an eye level. You can, you know, all of these buildings need to be here and the street needs to be is here and all of this information, but I can also make myself at a human scale and experience what it's like to walk down the street and this building so tall. And maybe that will inspire the designer to, you know, curve an edge or something to make it more softer for the human experience. Oh, I didn't mean to click on that, but this is a pretty interesting site called Digital Blue Phone. So you can see all of the different statistics and things you can explore, traffic, scenarios, vegetation, CO2, sea rise levels, things like that. That's very interesting. And there's a ton of other information for spatial analytics, using AI to calculate costs and things like that. Yeah. Okay. We can also use extended reality to gather more data. We'll talk about more why data is super important for AI, but just to say, you could use virtual reality for eye tracking, for example. Like, you know, all of these technologies could be used for good or evil. For example, you know, we're talking about theory. So, you know, imagine a retail store collecting this data of eye tracking so that they can position products to be to be bots. And that's kind of interesting because data is so important for AI that they might design the retail space to encourage you to stay longer, even if you don't purchase, because there is a value in them collecting your data. Kind of like when you go to a website. Actually, when you're going on the website, you're sharing a lot of data. You're sharing where your mouse goes, where your focus is. There's eye tracking, through these web browsers as well, and where do you stay longer? This is super common with social media apps. It's all just collecting your data, using it to sell you things, and or selling it to other companies so they can sell you things or political ideologies. But nonetheless, so you can use it for good as well. Imagine an interior designer. This is something I've always wanted to do. Sorry, I'm just going back to a comment. This Sora showcase was done by you or for Tim Fu? No, it was done by Tim Fu. Yeah, I did not create it. I put his name on there for sure. Let's look. Just to make sure. I think maybe the comments are delayed a bit, but yeah, this is by Tim Fu. He's doing research for Sora at the moment. Okay, so like I was saying, so imagine an interior designer putting the VR headset on their client and having the client just spend some time with it how they normally would, or I guess how they normally would if they had a VR headset on. But the VR headset will get smaller and more, or augmented reality. I mean, there's already glasses, regular looking glasses for this. But yeah, you could collect so much information about how the client moves through the space, where they like to be. Do they spend a lot of time near the window, or do they tend to be more, in a book or something? You could track like how they spend their time at home or in the space, and use that data to design a space that's more conducive to their lifestyle and maybe healthier. And then here we have something similar. Yes, so a heat map tracking where they're looking and spending time, much like we do on web browsers. So yes, so virtual reality is kind of, we're bringing the digital world into the physical world and vice versa. So this is really interesting for interior design. Oh. So let me do that again. So this is really cool with design where you could actively design your space and in a way fabricate, right? Have the product shipped to you. So there you go. So imagine someone or a designer could actively go around the space and just say what they want, and then accrue a bill at the end to implement it. Okay, or they can swipe through different furniture layouts for their space, which is really cool. This is all AI research and VR research being done for Shopify. And this one. Okay, so yeah, a much more immersive way of shopping and designing for space. It cuts out a ton of time in between. I know as an interior designer in the past, I would spend so much time creating the presentation boards and, you know, all of the presentations that I would have to do to communicate these ideas. I could just be there with the client or without recording, streaming my view with the client, and we could design and talk through this space in real time and be done by the end of the phone call. Hopefully you guys are hearing these videos. Yeah, there's a bit of speech in the videos, so. Okay, and finally, you don't hear the videos. Okay. Darn, I wish I knew that. I will talk through them. Okay. Thank you for letting me know. So digital twins of objects. So we hear a lot about digital twins of people. There are even political leaders now that are digital twins. They've created a digital twin of themselves that the AI digital twin presents itself, and the person is behind in an office, hidden, protected. But that's kind of actually a very basic level of a digital twin. A full-fledged digital twin is when it actually has data live streaming to it. And so imagine in architecture, you have your 3D model and it has stats on the HVAC, the heating, cooling system, what's the temperature, how's the plumbing doing, is everything working? So that's a great digital twin. The first example of a digital twin was this guy, Apollo 13 with NASA. It is actually, because it was a digital twin, is the reason the astronauts survived. I don't know if you watched Apollo 13, you're probably familiar with it. But that was because someone on Earth could go to the digital twin, the 3D model, and see what was going on in one part of the ship, the spacecraft, that the astronauts could have never accessed themselves. And from Earth, they could troubleshoot it, and it ended up saving their lives. So digital twins, super interesting. You could create a digital twin of a piece of land, so you could monitor climate change, sea levels, things like that. You could have a digital twin of your cup. Wow, can't see it. Of your cup, and it could tell you what the temperature is at the moment, and maybe you can, from your phone, control its temperature. Things like that. So it's super important, because imagine a wing of an airplane. It would be incredibly impossible to, just before a flight, there's a red light, you don't want to take off, but you don't want to open up an entire wing and try to figure out what's going on. you want to go to the digital twin and see how the stats are or what's going on. Are there any issues? And you can solve it there. And then wherever there is a physical issue that you would need to get to, you would know exactly where you would need to go without having to open up the entire thing. And also it can analyze that data and predict based off that data what will happen. Like I was saying, you could use it monitoring a piece of land to see if where the sea levels are, things like that. There's actually a good example here. Oh, I didn't mean to click on that. I forget that I put these examples, but this is a great digital twin. Let's see. So they have a digital twin of the entire facility, so they can monitor a bunch of things like safety, productivity, efficiency, if there's any issues. They have a really great example here. So they can map out the main traffic ways. And by collecting this data and monitoring it, you can also see where maybe you can get from A to B more efficiently or quicker. So imagine there's a hazard, there's an issue here. The digital twin will have that information, warn people so they don't go there, or someone goes there immediately and controls it. They can have these robots that are functioning at the same time. And there can be an AI that informs the team what's happening. So this could be used in a million ways. Okay, let's go back. Oh, I keep clicking it. Okay. And I did it again. All right, one more time. Live demos. Okay. So I'm sad that you can't hear the sound. Oh, that might have something to do with it. Please let me know if you can hear the sound now. But this is an interesting use case. Okay, sounds like you still can't hear it. Right. Okay, so what's going on here is there's this island, Tuvalu, is looking at very serious climate change, and they're at risk of this island completely going under water. And there are many concerns, of course. So they created a digital twin of the entire island so that they could monitor this information. They used the LiDAR scanner and drones to scan in the entire island and monitor it. But there's also the concern of losing their culture, right? They want to preserve the culture digitally as a solution. This is super interesting because so many people are concerned about technology kind of taking us away from our culture, our heritage, but this is a really impressive example of how we can actually preserve our culture and heritage. They also, because if it's all flooded, how will they show their nationality? So they actually created NFTs for each citizen. And these countries have recognized it as well, so that they will have citizen rights globally. So let's see. Show you some examples of how they're preserving their culture, and even with preserving the language, so that if anyone wanted to learn about it, like we are now, or future generations can learn about their heritage and their culture and the stories of the elders. It's a really beautiful project. Okay, so those are the user cases I have for today. We'll move on to mechanics, but before that, I just want to make sure no questions. You guys are good? Okay, nothing yet. Okay, so mechanics of AI. So again, like I was saying, we want to understand the framework of how AI works so that we can use it better and more empowered. I passionately believe that AI technology shouldn't be limited to people with a tech background. So it asked if I use Comfy UI. Yes, use it for stable diffusion. We're not going to go over stable diffusion tomorrow. It's a bit more advanced, and there's quite a bit of a barrier in installing it, things like that. But if you got my email, I will have in the newsletter instructions on how to download it easier, and how you can use it for fine-tuning your designs, or fine-tuning the model with your designs. Tomorrow we'll go over something a lot more simple, because I do want to cover quite a bit of things that you can do theoretically and practically with AI. And if you guys want to take things further, deeper, I can share more resources on that later. Like I said, I'll make more YouTube videos. I plan on making one for Comfy UI, actually. So the mechanics. So we'll do an overview of just the landscape of AI technology. Large language models, which is like the natural language processors, like you guys are probably really familiar with ChatGPT. That's a large language model. Diffusion model, like Comfy UI. It's a stable diffusion is a diffusion model that generates images or sometimes videos. And image capturing, like we talked about LiDAR scanning. There are a few other important image capturing tools that you can use, like high-end tools from a fab lab, or if you work at an architecture firm, they might have it there, or using your smartphone. Okay, but before all of that, I want to make sure that we understand the difference between AI and AGI. We've been talking about AI, but AGI kind of gets mixed in there in the prospects of the future. AGI, so AI, I really like this definition of AI from DeepMind Google. Computer systems that turn information and data into knowledge. This is because it takes all of the data, it synthesizes and analyzes it, and then it outputs knowledge, right? Something that makes sense to us. It connects a lot of the dots for us. Well, AGI is a computer that would substitute humans in all applicable tasks. So AGI would be like, we need a new building here. The AI, the AGI, would generate the building, generate the design, the construction drawings, the 3D models, the would start have robots, maybe even fabricating it. It can do all of the things without a human in the loop. We haven't reached AGI. Well, some people argue that we use artificial intelligence now generally, and it's artificial general intelligence, so we're using it generally. Okay, sure. Kind of semantics, but AGI, a lot of people predict that, people just a couple years ago were predicting it would be here in like 20 years. A year ago, people were predicting, like 10, maybe 5. Now people are predicting 2, 3 years. So this is always changing, and it's kind of fluid in what even AGI means. But how I want to frame it is that there isn't a human in the loop. And I think that's very dangerous and not so ethical. Like, I think there should always be a human in the loop. And so it's safer for all of us. And I think there are different kinds of intelligence, and AI as we know it only has a certain kind of data-based, while we have a different kind of intelligence that is essential in creating and building our world. So I'm super pro AI and even AGI, but I believe that there should be a human in the loop at all times. And I hope that we hold this value, the value for humanity, when using AI in the future, as a safeguard. All right, so let's see. So the landscape of AI, an overview. So artificial intelligence, not that young, not that old. So like I was saying, it goes back to ancient philosophy, the idea of thinking machines. This is something we've been striving for a long time. And we made headways in the 50s with Alan Turing, actually creating a thinking computer, to the 80s and 90s. And now we've had just this huge boom of generative AI for the most part. So we'll talk about the difference between AI and generative AI and how we got there. But so we have artificial intelligence that encompasses all of these concepts. So you hear AI used a lot. Well, this is why, because it actually encompasses a lot of different things, including machine learning. So a lot of you guys probably use machine learning for your design projects already. We haven't been calling it AI, but we'll probably start to. So machine learning is when a computer has data and can do actions from that data. So yeah, and then neural networks is when those different data points can be connected in new ways. We'll talk more about neural networks in a bit. Deep learning it really connects those data points in a lot of new ways, while generative AI, it generates new things from it, like we were talking about with diffusion models and large language models. And then large language model is a subset of generative AI, large language models, that we'll talk more about how that works as well. So let's get a little bit into it. So I was saying artificial intelligence, not super old in a sense, a great example of artificial intelligence is Google Translate. And we've had that for quite a bit now. Or Google Maps. It is able to use AI to figure out how to get from point A to point B with a bunch of different complexities of like traffic and different modalities of transportation and or do I want to walk, or do I want to avoid the street? Like there's a bunch of things, a bunch of data that goes into this AI model that we've been using for years now. Or Alexa is a really great example of AI that can recognize your speech, generate speech. Yeah. So these are all different concepts that I'll touch on just broadly as a concept to kind of have in the back of your head as you approach these tools. So with artificial intelligence, we'll talk about computer vision. With machine learning, we'll talk about unsupervised, semi-supervised reinforcement and reinforcement learning. With neural networks, we'll talk about CNNs, gains, and backpropagation. And I'll tell you what that all means in a second. We'll also go into deep learning, generative AI. We'll talk about diffusion models and large language models and how it generates text. So we'll first start with computer vision. So what is computer vision? If we look at it compared to human vision, it works pretty similarly to our eyes and our brain. So the eyes would be your camera and the brain would be the laptop. So one's a sensing device and one's an interpreter. So if I look at something like a bowl of fruit, my eye senses it and captures it in the environment. And then my brain interprets it and tries to understand this image of a bowl of fruit. And then you're like, yeah, it's a bowl. There's oranges, bananas, lemons, peaches. Then a computer does something very similar. It has the input of the image. It can interpret it based off of patterns and data. We'll talk more about that later. And then it can output that it's a bowl of oranges, bananas, lemons, and peaches. Computer vision can also classify images. So like I was saying, you can see the bowl of fruit, say it's a bowl of fruits, but it can also say there's oranges, peaches, and lemons. That's detection. So we see here, it can see multiple objects. And segmentation is when it gets even more detailed with what it's seeing, pretty much. I'm just going over these things generally. I know I'm not teaching computer science totally. I just want you as designers to, or creatives, to kind of understand the frameworks. So we have machine learning. The three different kinds of machine learning. We have unsupervised, semi-supervised, and reinforced. So unsupervised is the data has no labels. So, you know, the bowl of fruit, it's just an image of a bowl of fruit. It's not saying that it's a bowl of fruit with peaches and oranges. So it's just like unlabeled data. Semi-supervised is some of that data is labeled, which is very helpful because it can interpret that data and find patterns in the unlabeled data. And then reinforced learning is, it's kind of like a reward system. So it can penalize or reward an action, or interpretation. So I'll get a little bit more into that. So again, so unsupervised, no labels, semi-supervised, some labels. There's also supervised learning, which is all labeled. And then reinforcement learning, which has like a reward system. So unsupervised, unlabeled data is super helpful because it can find the patterns and group, cluster, different things together. So if something's not organized yet, you can use AI to organize it. So, and that's helpful because you can get insight to find out if there's something you kind of like aren't seeing, like this invisible string between all of these things. AI can help you see it, which is super helpful with like brainstorming or doing research on why you like a certain aesthetic or a product or something. You can use AI to kind of analyze what's the reoccurring theme. Semi-supervised, super interesting. You add in some labeled data with it, which gives it some like a starting point of what you're looking for and what you're interested in. So, I send an image of that bowl of fruits, and it's labeled bowl of fruit with oranges and peaches and so on. And then I also submit an image with no label that is a plate of strawberries. It's going to be able to deduce a bit that it's fruit, there's a plate. It's helpful data. Reinforced learning is really good for like robots. So if you can get this robot can go to the other side of the room, it will be rewarded with doing the right thing. And if it doesn't, I'm not coming up with a good example here, but I think you get the idea, and this will make more sense as we go through more examples. This is kind of just basic. Convolutional neural network, CNN. Here we have an artificial neural network, which was originally modeled off of mathematically, the human brain. And so if you think of these points as neurons in the brain and these lines that connect them as the synapses, well, these points are just points of data. And when it makes these connections, it's essentially like having ideas. So imagine you put this image unlabeled of a bird, and it puts this data into the machine, and it goes through this hidden layer, which we'll talk more about later. And the output is, well, it's likely that it's an animal. It can like kind of deduce the potential the potential label, right? And then it will use statistics to determine which one is more probable. Well, if it has a bunch of data of images of birds that are labeled bird, it will be able to do much more easier that this is a bird. I can see the patterns of the shape or the hex code. We'll talk more about that later, of a bird. And it will be able to tell like, hey, this is likely a bird. And it's gotten really good at this. And we'll talk more about how the more examples you have or the more labeled data that you have, the more accurate the output will be. And then, so this was, no, I don't know what that is. But sorry, just going to clear this really quick. I think I have too much happening. So then we were able to just discover or figure out how to go the opposite direction. So instead of starting with the image, now we have so many images that have been labeled by AI that it's a bird. Now, if I type the word bird, it can figure out how to generate an image of a bird. And again, this is based off of statistics and patterns. But yes, this is called backpropagation from text to image. Oh, no. Sorry. So what's really cool or scary, I'm not sure yet, I think it's very cool, is that we were able to figure out how to create, so we were able to figure out how to create images to be labels. And then we figured out how to turn labels into images. And now we can figure out how to create images out of our thoughts. So they found that with an fMRI, they were able to generate images of what the person is seeing. So there's visual stimulus, and it generates the image, and it's pretty good. I think this was from like a year ago, so I'm sure it's much better now. Yeah, so imagine, theoretically, you could dream, and when you wake up, you have this roll of footage that was generated from your dreams that you can use somehow, whether you share it, you use it as your inspiration for your projects, or even as you're talking to your client, for example, or general, anyone. You can be thinking what your idea is for a project or a design and immediately project that idea. Instead of going through all of this time of generating just the right image of what I'm thinking about, can I prompt it right? You can just think it. And that's incredibly powerful, of course. And I think it's super important to think about, because how powerful our thoughts will be. So a big part of prompting, what you type in or speak, or, whatever you input into an AI, shows intention. And the clearer you can be about your intention, the better you'll be at prompting. The better and closer you'll get an output to what you want, right? And so I think it's really important that we have good thoughts, right? And that they're conducive to society. But yeah, so that we feed a healthy visual stimulus. So I just say this because a lot of people, have these scary sci-fi ideas about AI in the future. Well, you can create that future if you're kind of stuck on it as well, or you can create the opposite if you kind of more hopeful and you see a possibility for a world that is productive and healthy. You can generate productive and healthy worlds. So this is far into the future, but it's happening now. But as far as accessibility goes, it is far into the future. But I think it's really good to think about, so we can get our minds right before we have this power. Okay, so now let's talk about the diffusion model. So a diffusion model, it essentially starts off as a noisy image. It's just a bunch of random pixels. And based off of your prompt, it tries to find your prompt in the noise. It finds patterns, creates patterns, and tries to find the noise. Actually, I have like a really good example of that could be interesting. I'll put it in the newsletter. It's a music video that used a diffusion model to create some really cool scenes, but essentially, like, it just tried to find patterns of dogs, actually, in what it was seeing. And a lot of times it didn't make sense. It was just like there needed to be some sort of noise for the patterns to grab onto to generate the visual. But nonetheless, it starts off as a noisy image, tries to find the patterns, and does this about 100 times until it gets to the final image that you see. If you use these more technical AI image generators, you get to see that process. Like if you use Midjourney in Discord, you get to see it diffuse, which is really cool. And you can even stop it wherever you want, which is neat. Like you can say, oh, I only want it to do 50 iterations, not the full 100. So it's just like an interesting form of art you could play with. So what do I mean by noise? These pixels. It's kind of like the old TVs when you would turn them on and there was all of that static. It starts that exact way. Those are called hex codes. I think my next slide explains it. And then a clean image is this like fully developed image. And the word clean is used a lot with tech and data, because now this is usable. Clean, like you can clean data. Clean data is data I can use really well and efficiently, and I don't need to alter anything to get it right. It communicates the idea fully that this is a cat. It's a clean image. And I keep clicking. Okay. So, yes, so noise. So there are pixels in a certain order. They're called hex codes here. You can see. So you have an image, and there are these numbers assigned to it. So if you zoomed in, you would see all of these numbers. You can find these tools online, so you can create your own. I think I have one attached. Yes. So I could upload an image and it will show me the hex code. So I'm going to do that. Bear with me while I grab an image. Okay, I'll use this image. Okay, this image I generated for this workshop, one of the images. So it's processing. So yes, this is the hex code output for, it's a big image with a lot going on. So I could copy it, manipulate it, embed it. I could do a lot of things here, but it's hex code. So it's similar to if you're in graphic design or if you use like color coding. So RBJ, I'm going blank right now. It has that number of like how much red, how much blue, and how much green. RBG is in it, and it has that assigned number. And it just takes that one pixel with that one color, right? And then you zoom out and it creates the image. It works the same way. Okay. Okay. So, and that's just to say what we're, because people like, you know, AI is very much modeled after human intelligence and how our brain works and all of that, right? In theory, mathematically. But it actually doesn't, it's not really understanding or experiencing how you're interacting with it in the way you are, right? So it's generating this really cool image, but it's just numbers for it. It doesn't really interpret it the way we do. We're the ones that are enforcing our labels onto it, right? So we're experiencing it one way, but on its end, it's just a bunch of numbers. It's like a calculator. So we absolutely control what it generates, is my point. So with generative adversarial networks, GANs, we can see it starts with that random noise. It goes through a generator that generates the fake image, but it does this with the data set, the training set of real images. And then there's a discriminator that discriminates, does this look real enough like my training set? And we decide actually if it's real or fake. If we keep the photo or if we keep enhancing it or developing it, we're investing further in those pathways, those patterns. We're rewarding the AI to generate more like that. And so we'll get into ethics later, but yeah, what is AI trained on? And is it outdated? Those are good questions. But yeah, like there's a lot here. So this is why it's important that we engage with it. I've met a lot of people that are afraid of AI, and I totally understand, and are kind of taking the back seat. I don't think anyone here is, because you're in this call, but and you're interested in the topic. But my point is the more you engage with it, the more it develops around your values. And so I think it's really important from like a grassroots level that we all engage with it, especially the designers, the ones that want to create the future for humanity, engages with it, and that it's not just limited to tech companies or governments or things like big businesses, but that we have a huge say in how it develops. So as you engage with it, you develop it. You can also create your own model. Hopefully you're not hearing this noise and the AI is working, but you can create your own model. Like someone was saying, asking about Comfy U earlier. You can create a model that just exists on your hardware that isn't shared with the public, because a lot of these AI image generators they collect the data, and that's how they fund this technology, and sometimes profit. But you can use these open source models that you can download on your hardware that aren't connected to the internet, and you can develop those models specifically just on your projects. So this is, I think, essential for any architecture firm that is embracing technology, is that they would develop their own model trained on their past projects that they like, their portfolio, and even research and things like that for the type of work that they want to be doing. If you wrote a book on your ethos and design, things like that, these are all things you could train your model on. And then it would generate more of that, which is super cool if you've, especially it can help you understand what your style is, how you can refine it, or explore a little bit more. Cool. So what I'm saying is that you can fine-tune, hone your own model, or if you engage with it publicly, like online, you will help fine-tune AI models that are used publicly. So you would influence what other people see as well. Okay, so now we're getting into image capturing. There are these four main, I would say, types of capturing tools. Perhaps you've already used capturing tools. I know at the Fab Lab, we have a really nice LiDAR scanner that is super accurate. But a lot, or all of these, actually, you can use from your phone. It's not, of course, as good as like a high-end professional one, although if you have an iPhone, it's probably good enough, I would say. You could really go far with the iPhone's LiDAR scanner, or even the, I think the Apple, the pad. Why can't I think of it right now? That also has a LiDAR scanner, the newer ones. Anyway, so we have NERF, LiDAR, photogrammetry in Gaussian splatting. NERF uses AI to construct the 3D model from 2D images. A LiDAR scanner uses a laser, so uses light detection. And so imagine a laser shooting through, and how far it goes and hits the object is that the measurement relative to the camera and the object, and it collects all of that data to create a model. So this is really good for a lot of things. It's used a lot in architecture, urban planning, agriculture. I use it a lot for product design. I can scan in objects. I can have a whole library of objects on my phone, of things that I've scanned in, or there's often public databases of things that people scanned in that I can use and build really quickly from. And then photogrammetry is when photos are taken and then stitched together kind of like a quilt to create the 3D model and the textures. This is super accessible, very cheap. Any phone can do this. I will show you some tricks and how then you could even do a video this way and use an AI to stitch those shots in the video, right? You have a long video, which is a bunch of photos, takes those photos, stitches it together to create the 3D model. And then we have Gaussian splatting, which is point clouds. Super cool. I think this is the future and the past. It's one of the first forms of image capturing, but I think it's the future. So it's creating a little point in a cloud, right? So this is super cool. From far away, it looks real, it looks identical. You zoom in space, right? You could do this in VR, or you could do it on your computer. You zoom in, and then there's just like these dots of color, kind of like pixels. But imagine the pixel is 3D spheres. So imagine, yeah, like hex codes. I think there's so much that could happen here. So instead of pixels or hex codes or whatever, we would have these little clouds. So when we generate with AI, we could create these point clouds really efficiently that we can zoom in and scale. We can move those point clouds to morph it. You can clean it up very easily. Anyways, these are all very cool. Photogrammetry, super accessible. LiDAR, if you have an iPhone, please use it and explore. Tomorrow during practice, I will explain like the main apps that you can use, free, how you can use them, what they're cool for, so on. So how you actually capture the image. So it's just taking, depending on the modality, you have one point of reference, and you're either taking a photo or a laser or whatever. In this example, we're looking at nerves. Did I put nerves on here? Yeah, nerves. So you're just like going around the object, capturing as much data as possible so that AI can stitch it all together to create a model that you can then alter and edit and fabricate very quickly. Okay. So yeah, if you haven't done that, very interesting. So imagine you want to design a chair. The chair you're sitting on is really great, fits your body really well, but you want a different design, but you really like the shape. So you can scan it in, take it into your 3D modeling software of choice, and then you can start to alter it, change the color, change, the texture, or add another shape to it, another volume. The possibilities are endless. And so this is kind of just displaying another example of how you shoot out, capturing that data, and from your point of reference, it's just a flat image for a nerve, for example, or photogrammetry. And yeah, but even if you took out this photo and you just looked at these points, it would be like Gaussian splatting because it's all of these points of information that it captured. I think this is interesting. This is kind of a stretch, but it reminds me a lot of the artificial neural network where you have the neurons and the synapses. We can kind of start to think about 3D objects this way. It's kind of abstract, but I think there's something there. Okay. Let's see. So let's talk about equirectangular, projection. So when we talk about 360 worlds, it's essentially an image that wraps around into a sphere. But there's a certain kind of logic to it, of course. When we see, it's 360, right? It wraps around us. There's, some distances are closer or further, right? There's a lot going on. So we want to generate images with this in mind. For example, we usually focus in the center, right? The center. But all the way on the left and all the way on the right should match. If I went all the way up and all the way down, should match, right? They should connect eventually. So the same thing goes. So like if I was just going to create an image, let's say you're going to create an image in Midjourney, you would need to make sure that the top and the bottom fit, which is kind of tricky. And that's why we'll use other AIs to generate these 360 wraps. But you could generate the image and then take it into like Photoshop and start to edit the left and the right so that they do match. Easier with some scenes than others. Like imagine you just have sky on the left and the right. You just need to make sure the color matches. And that the top and the bottom match. So a way to think about it, an example we all know is of the world map. So like I was saying, some things kind of get distorted as they curve, right? So if we look at the equator, everything's pretty accurate to scale. It's kind of the flattest part. It's the part closest to the viewer. And then things kind of start to morph as it goes out. Yeah. And yeah, so you can kind of, we talked about 3D worlds. The world is a great example that we are all familiar with. All the way left and all the way right matches, top and bottom. You have the poles. But there's also a distortion that happens by projection. So there are these different distortions. So if you just created an image, for example, if you just created an image in Midjourney, you did the photoshopping, but you didn't consider these projections, these distortions, then it would look weird. It would look off because it's not distorted. It would look distorted to our eye because it's not distorted. So if you put it in your VR headset and you viewed it, it would look strange and it would make you a little uncomfortable. Because yeah, it's just a little too artificial. But there are ways around it, and I think there's a lot of room for a new app. Someone needs to make it of just generating these distortions as a filter layer that you put on top. Why I haven't found this yet. If anyone has found this, please let me know. Yeah, so the top and the bottom match. You have these distortions that meet up on the sides. You can see here in the center where the equator is a perfect circle. Actually, it's the only perfect circles. And the aspect ratio is 2:1. So if you were going to generate it in Midjourney, you would, use this AR 2:1. And this is, again, that filter on top so you can see what is left, what is right, up, down, and then the back. All the way left and all the way right is the back. Okay, so we kind of covered imagery, image capturing, diffusion model. Now I wanted to get into the final set of mechanics that we should consider, which is large language models, which I know we're in design and we're heavily visually based, but we're going to use text to generate images as well, or we're going to use text to brainstorm or refine our concepts. So it's really important that we also understand how large language models work. So here's the gist. It's essentially a chunk of the internet. A lot of it is trained on just the internet. I mean, there's a ton of stuff on the internet. So imagine this web of the internet being processed in data centers. So a GPU, a graphics processing unit, like our laptops have CPUs. A GPU is a computer chip managed by many math tasks at once. GPUs are much more efficient than CPUs. And now we have a bit of a race towards GPUs and having more power to store more data. Nonetheless, it can be very expensive. So in this example, for a large language model, they process quite a bit of the internet, and it took 6,000 GPUs over 12 days, which cost $2 million, which is why you'll find a lot of AI applications just on the backs of existing large language models. So like OpenAI powers a ton of other AI apps. A good one even is Perplexity for research is great, but it's just powered by OpenAI because it's incredibly expensive to create a large language model. But there's ways around it, like renting servers. Okay, that's a whole other conversation. Anyways, it's then compressed. The data is compressed a lot like a zip file. So it can compress so much data into, in this example, we went from 10 terabytes to 140 gigabyte file. So it can compress a lot of data. And how does it work? So there's something called tokens you might already be familiar with. Tokens are just like assigned numbers, if I was going to put it simply, to each word or symbol. Let's say each word. So here we have my favorite color is red. Well, what the AI is actually seeing is just these numbers, these string of numbers. So this is kind of fun to see, because with these different AI apps, you are limited. This link doesn't work. You are you are limited to certain number of tokens, depending on your membership or subscription. So it can be helpful, especially if you start using AI at large scale. You'll want to know how many tokens you're using, so you don't run out, and so you can budget for it. So especially if you use like for automated tasks and things like that. So hi, hello, how are you doing? Sure. So you can see just that is 8 tokens, 28 characters. Each one of these is a string of numbers. If I put doing, yeah, so doing is 3815, 3815. The question mark is 30. So again, kind of like what I was saying about AI, it doesn't experience the conversation the way you are. Like we're looking at these images, it's not seeing what you're seeing. It's just seeing these numbers. So it works like a calculator. And be kind of that simple. And furthermore, how does it generate text? So it actually is just predicting the next word based off of probability. So a lot like texting on your phone, how it can just predict the next word. That is pretty much how it works. But it's doing it every time it creates a new word or a new token. It will go through the entire process again of finding the next most probable word. So if I wrote once upon, and then it would be like, okay, it's most likely they're going to say A, and then it goes to the machine again. Okay, once upon A, and it's going to predict time. It's going to go again. Once upon a time, there. And then then it probably gets really creative and starts a whole new story. But how many times in books that start with once upon a time, it is embedded in the model that these words would probably be strung, or these numbers, these tokens would be strung together. And it kind of works kind of how I was saying, that reward system, or, based off of probability, it's going to go for A. It's more probable, as a 0.5 chance of being what you want than if it went with the or for, and so on. So again, it's just grabbing the most probable word. For example, if I wrote once upon a time, and then it gets creative. So it's always probably more than likely going to be once upon a time. Yes. Okay. Okay. So let's talk about the process of training these models, I guess. So a big part of it, like I've been saying, data. It's about data collection. So in the context of design, this could be site surveys. That's a lot of data that's being collected. Environmental conditions, a lot of data you could collect there. Historical architectural styles in the area, that's great data. Building codes, so you can see what are the design challenges, right? The structure of the whole design, and what are the client requirements. Then you can also add information you get from the LiDAR scans, photogrammetry. You can have drones collecting live data that you stream to your computer, and can always start to evolve and develop the design during the design process. And then AI can synthesize that. It can use algorithms to analyze the data and generate structural integrity. So imagine like you're building somewhere that's susceptible to tsunamis, and but it has this cultural, historical style, and there are this many people that live there and this many cars that drive by. There's all of this data that could be used to then generate the design that informs the design. And then you have the final model that can be generated with AI as well, that can be very detailed and textured, that you can use for simulation, for virtual reality, extended reality. You can use it for client presentations, of course, and eventually for construction planning. With all of this, again, I think it's super important for human to be in the loop. Like we were talking about AGI, that's more like it's doing all of this and it's not checking in with us at any point, making decisions without our approval, active approval. Okay, so but I strongly believe that AI enhances our cognitive and creative abilities. Like we were saying, it is designed mathematically, the artificial neural network, here is designed off of our brains and how we can have certain pathways that we invest in that like further builds thoughts. AI does the same. But yeah, so also AI can see more as our world becomes more and more digital. AI can see in a way that we can't, right? So with like pixels and hex codes and all of that, it can see those things we couldn't see. And so as we live more in the digital sphere, it can really help us understand what's happening and inform our decisions. It can, collect more information and data at the same time in different languages and cultures than we could ever in a lifetime. And so this is a privilege that we get to explore and utilize. And all at the same time, to do it ethically that like actually helps society develop. It's good for you to be engaged. But it does have its technical challenges. So if you're designers working in spatial computing or renderings, you probably know what I'm talking about here. Very frustrating aspect, especially as an interior designer. There's all of these like faulty points of technology that it can't see like we can, right? And also we shouldn't be totally dependent on it because like here we could have some sort of outage, right? So it's a companion. It's like it's a co-pilot. It's a collaborator. It's not everything. We work together. And we can pick up where it leaves off and it can pick up where we leave off. But it's an addition to us. So some other, this is why it's important that humans are in the loop, right? Because it can hallucinate. AI can absolutely hallucinate. You probably have heard this quite a bit lately about AI hallucinations. So what are they? It's like when AI makes pretty plausible but untrue statements or images, things that just aren't right but are so believable because it still is based off of data we fed it. It just made weird connections. And it's preventable. And it's also something you can use to your advantage. Like if you do want hallucinations, you do want to have something that's a little bit more out there, creative. But the possible causes is that there wasn't enough training data. A really cool example, everyone talks about how AI cannot generate a good hand, or often it's one of the giveaways is that the hand looks weird, there's an extra finger or something. But if you gave it more data, if you said, well, the hands are actually positioned in prayer mode and it's just under their chin, and you gave it more data, more context, you wouldn't have that issue. And you should try it out. We can try it out tomorrow. It just needs more context because especially the hand, that's why it happens so often, is that hands could be doing so many things. We have such versatile instruments. It could be doing so many things. It could be in the photo, it could not be in the photo, it could be, hidden or not, holding something, whatever. It could be doing so many things. So we need to give it context so that it can generate better. Otherwise, it will hallucinate. It will try to make connections that aren't there because it's just like striving. It's just like trying to grab anything to put together. It can also be data that's unclear or biased. That's a really big problem with AI is bias data. A lot of the data, like I said, is from the internet, and early internet was maybe a bit toxic and had old ideas that we've already worked past. Also, it's not just the internet, right? The internet is full of books and libraries of books. So there's a lot of outdated ideas, and it makes AI very biased because, yeah, that data hasn't been cleaned or updated. So it can continue to hallucinate that the world or society is a certain way that it isn't or isn't any longer. So how you prevent that is you give it more context, you give it more data, more accurate current data. So, and then also giving it clear constraints, like I was saying with the hand, it's in prayer position, it's under the chin. You're giving it constraints, something to work with. So hallucinations, bad, but creativity is good. And you can't have one without the other. So it's kind of tricky, actually. We don't want to get rid of hallucinations completely, because actually this is kind of how our brain works. More so with hallucinogens, of course, but we do hallucinate in our dreams. So when we're sleeping, all of our neurons are firing off and making connections, new connections, which is healthy. And AI does the same thing. It can dream. But as we engage with it, we're telling it when it's dreaming is okay and when it isn't okay. And so it will evolve based off of our engagement. So, yeah, I created this image, for example, with that idea, the balancing act of creativity and when is it a hallucination. There's a lot of times when it hallucinates, we think it's really cool art. So how can I say if this is a hallucination or if it's just creative art? Are really interesting questions to consider. And I would say that is, as we talk about training our own models, that is what makes your aesthetic and your specific approach is what kind of creative input or output are you engaging with. So all to say, AI, great, amazing. AI plus human creativity, very good. But AI, human creativity, and specialized knowledge is where it's at. So I talk about yes, I want design to be democratized, to be accessible to all. Everyone should be able to express themselves and create the world they want. But if you're trained in the language of design, you'll generate way better. It's a huge difference. I've seen so many people create with AI, create interiors and architecture, and yeah, it's really cool, but why does the front door open up directly into the pool? Or, oh, really cool chair, but that would never gravitationally work. I mean, I'm glad we're playing with these ideas and stuff, but if you don't know how these things actually work, you can generate things that are hallucinations, don't have enough context. So yeah, specialized knowledge is very important. You can generate a lot of things with AI, right? Musicians use AI. You could generate music with AI like this now, and you don't need to be a musician. If you were a musician and you used AI to generate, it's a whole other game. Where how the structure of music works, and you can go in and tweak what note is here and there because what procession would work here, whatever. You can go in and edit. You can go in and fix what AI doesn't know. And you can give it more data. Like we were saying, AI is programmed with so much outdated data. But me, a human, I'm full of fresh data all the time. And I can feed it that fresh data and get something amazing that someone that isn't living in that world, that aren't thinking about those things, that hasn't been educated in those things, probably wouldn't get to. They have other things to offer that are interesting, and we can work in collaboration and things like that. But if we want to bring things to the real world, we of course need to have specialized knowledge. Okay. So it's a balancing act between technology and humanity. So I believe we need to invest in both equally. So AI doesn't have a lot of the intelligence that we have. We have a different kind of intelligence, right? We have intuition. We have common sense. We have emotional connection. We can build relationships, intimate relationships. We've had a mother, you know, we have a mother. There are things that AI will not be able to acquire. It can pretend to be those things, and those are really great ways to get a great AI generation, is actually to tell it to perform in a way like a human. For example, to imagine, when you generate images, to imagine is super impactful, to use that word. Or when we're using LLMs, to ask it to think. You ask it to think, it will perform better. Or you ask it to pause, take a breath. You know AI can't breathe, but if you ask it to take a breath, it will reflect more. It will create a better output. I'll show you tomorrow. But yeah, so it's both. And because AI can take care of all of these things for us, these like very kind of repetitive, data-based tasks, we can now flourish even more as humans, and we can build our humanity. Like, we can further explore what makes us unique and balance that out with AI and technology, so we can work together, both strengthening our strengths to create even better. So it's not linear. Our relationship with AI should not be linear. I don't just like tick, 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 input, create a house, and then bam, it creates the house, and I'm like, this house is not great. And like, AI's not great. Like, people, I've seen that a lot, like, oh, it can't do it. Well, it's not linear. It's not input and then output and you're done. It's a circular relationship or approach. It's an iterative process. So I start with my idea. I collect a lot of data to prompt with, give it new data, give it context, give it constraints, and then generate and evaluate the results, analyze the errors, reflect. Why did it not give me what I wanted? And then I give it that new data of, well, it didn't consider this, this, and that. Well, give it this, this, and that, and then it will consider it. And so we keep doing that, finding what's missing, how can we get closer? We keep doing it iteratively until we get the results that we want, and then maybe we're done. But yes, AI is super fast. It can do things really quick, but where it really shines is when it's like influenced by us throughout the whole process. You know, there's always a human in the loop. We are always influencing it, giving it restraints. It's super important. So And like I said, more data, the better. The more data it has, the better the performance. So a small AI model will create more hallucinations and it won't be very interesting, the output, versus if you have a lot of data, right? Yes, okay. So I think that's obvious. But here's an example. So because we're talking about fabrication, you can monitor the output of your fabrication throughout the process as well using AI and computer vision. So here, like we have the manufacturing line of clay cups, clay mugs. So I can have the AI assess the mix of the clay. Is the mix correct? I can have it assess the shape of the mug, if the glaze is right, where the glaze is at, the kiln, and then the final inspection. So for this to really work, I need to give it a training set. I need to give it a bunch of examples of mugs that I made or mugs in general that I like and I think are good. I need to give it that training set like I showed you with games. There's the training set that the discriminator compares to what the AI model generates. And for the result, the output to be accurate, we need more examples, right? Because imagine, okay, so here it's identifying that this mug is okay. This mug has a defect, and this mug is okay. So it figured that out, right? From the data, the labeled data. Another thing is you should label it correctly, right? So it's accurate. And then you have the test set. So it said this is okay, and this is defected. Okay. I think I messed up my graphic here. But anyways, it should have had, I think another, oh no, I didn't. I'm sorry. Okay, so because if it said that they were all okay when in fact one was defected, then it would be 66.7% correct, which is the majority correct. And that's just not good because I only gave it 3 examples. And compared to those 3 examples, it was 66.7% correct. But if I gave it 10 examples, then it would only be a much, I can't think right now. I think we should take a break soon, actually. But I think, so essentially what I'm trying to say is that the more training set that you give it, the more accurate the data will be, right? Ah, perfect. Wow. Perfect timing. Okay, so we're going to take a break. 15 minutes. I'll put a timer. And, well, actually, before the break, any questions? You guys good? After the break, we're going to move into ethics. Okay, no questions. Okay, so I'm going to put up during the break the questionnaire. So, what is real? So I just want to test your digital literacy of being able to tell what is AI, what isn't. This test takes just a couple minutes, really. So you don't have to do it. You can do it when you get back, whatever feels right. But I thought it would be fun to have something playing while during the 15-minute break, if you don't need the full 15 minutes. Oh, forgot. Okay, so I will see you in 15 minutes. And put this here. Turn off my camera. And put a timer. Okay. And we're back. I hope that was fun. Here are the slides again. If you need to record your answers, otherwise we'll just get right into it. I noticed we went a little, I've gone a little bit longer than planned. We have 18 minutes left, but I know I have more than 18 minutes of content. Would you like me to go over? Should I just cut it short? Let me know. Maybe I'll just, we won't have time for a debate. And if you have any questions, things like that, we can talk about it in the other 2 days. Otherwise, I will get right to it. Here are the answers. So the ones with the red border are real. The other one is not. As strange as this one is, it's real. This is part of a strange trend that's happening on Facebook with AI bots that are generating based off of what people are interested in. And it gets really weird. I'll show more examples later. Surprisingly, he's not real. They use stable diffusion for that. You can see you can create pretty realistic mood boards, even materiality. This was pretty chaotic. If you're an architect, you probably noticed. This one isn't real, but you can see how well the natural lighting is. And here we go. For 6 through 10, this was real. This isn't real. Amazing lighting. This wasn't real. This is real. This isn't real. This was real. And so on. And there's like little clues you could find. And it's important to be looking. Now, unfortunately, with any image, you really have to look closely to see if it's AI generated. So with this one, we have more realistic mountains. And if you look close enough, you'll see there's missing buildings. This is kind of repetitive. You'll see the diffusion happening. And here, you'll see that like arms or hands won't make sense. Things don't connect correctly. If you knew about ancient Egypt, you could be like, oh, these are real hieroglyphs. These aren't. Things like that. So there's clues in every single one of them that would give it away. And it's, yeah. So so this is called deepfakes, when something is kind of trying to get away as real. These two examples are thriving on Facebook. They are very much believed to be real, strangely enough, as weird as they get. Like this one is based again off of the algorithm of what people are looking at the longest and are looking up, are interested in, and these AI bots are just generating these images based off of that data. And it's really important to have digital literacy, especially for the aging population and the youth, that, you know, the brain sees it and would only assume it's real because they haven't had that experience or education of learning about these technologies. And also the development is happening super quick. So this video is only from a year ago of Will Smith eating spaghetti. Maybe you've seen it. It's super bizarre. And then this is Sora just now, I would say now. It's like huge progress in just a year. So you can only imagine a year from now how believable it will be, and those clues will be hard to find. So next we have ethics, or more so than before, I guess, where we went over deepfakes. We'll talk a little bit about geopolitics, transparency, and perhaps not a debate. I'll go through this pretty quickly. So I thought it was important to show this data of how much distrust there is in the world right now, and it is ever increasing in the age of AI. The darker hues of green are the places with more trust. These are places that were surveyed and agreed with the statement, most people can be trusted. And the places that are lighter are places that didn't agree that most people can be trusted and that you should be suspicious. This will only get worse. Like right now, it's horrible. And it's really a sensitive time because there are so many elections happening globally, where AI can generate some pretty believable content. And again, if you're not educated in it, you will be incredibly vulnerable to different agendas. And unfortunately, there is a correlation with the countries that don't believe people can be trusted, have a higher vulnerability to authoritarian ruling. So like dictatorships and things like that. When you don't have community, right? You are more vulnerable to powerful groups that lead and fearmonger. So it's super important that we are confident in ourselves in detecting AI-generated content and being aware that there are agendas behind them. And AI is super affecting geopolitics. I just look at these three of the main, I would say the main ones are the US and China are really leading the way with AI develop. I mean, there's of course other countries as well, India and Canada. And I could go on and on, but I had to simplify this slide just to make the point. In Europe, there are a lot of laws that protect humanity, like GDPR, the new AI Act that's going into law right now, that is focused on making sure that people aren't vulnerable to AI in as far as people profiting off of them and using their data without consent. You know, of course, we want to safeguard AI. If it's effective, that's another story. And it's a delicate act of balancing safeguarding versus limiting innovation is a whole other topic. And then in the US, there is a lot of investment in AI, but in the laws around AI that are being developed have quite a bit of loopholes in the interest of corporations and the government. So right now we're looking at high investment of AI in the military and commercial gain. And then in China and some other countries, we're seeing AI being invested for state power. So governance and social control. So it has a lot of concerns about data privacy. And overall, if we're talking about geopolitics, the whole world, I saw a really great graphic that I wish I made a slide on, but it showed that countries in Asia are incredibly invested in AI and into AI and excited about it and are all in. And when you actually look at the US and Europe, they're like way down here. So Asia is very much full throttle going for AI, while US and Europe not so much. So it's kind of contextual. There's a lot going on. And I tried to simplify it as much as possible to communicate the landscape. But I also wanted to bring awareness to all that goes into AI. It's not just a cloud in the sky. It's under your feet. It's made of earth, and it requires a lot of human labor. Some in data centers, in offices, or even remote workers, data labeling, and others with a very high human cost, to the worst extents. So there's a lot of, as AI is at the moment, it does come with a cost, and it is good to be aware, so we can work towards and invest in the solutions that it doesn't have to be this way, right? There doesn't have to be the human cost. There doesn't have to be the cost of the earth, which can be leading to climate change, protests, a lot of instability, an arms race, and all of these conflicts around different resources. I believe in actually, I believe we need more energy. I think energy helps us use technology that makes our life much better and in the lives of everywhere around the world. It's not just for certain groups of people to enjoy, it's for everyone. AI could be totally 100% clean energy. There are several solutions out there right now that we could be investing in. The obvious is, wind power, and it could be harvested in Northern Europe, or geothermal energy in Iceland, or solar energy in Southwest USA. Or I didn't put it here, but I really like assistant professor in University of Porto here in Portugal, Maria Braga, invented these really cool glass batteries that are can charge way more than a lithium battery, and are safer, and don't compromise the earth as much. Or there's Microsoft just came up with another great alternative for a solid state electrolyte. It took only 80 hours to discover using AI. AI did an analysis of all of the different materials, natural resources that we could use as alternative ways of using it, and within 80 hours found something that could reduce lithium use by 70%. So, I mean, we could totally wipe out these issues that we're talking about in the matter of days, if our focus is there. Yes, and of course, AI can be used to make us more sustainable, with resource optimization. So like I was saying with the drones that can just water where it's needed instead of what we're doing now where it just like shoots water everywhere and hopefully works out. Things like that. But yeah, so I'm super optimistic, and I think it's only a matter of time. I would fully, I think, identify at this point with solar punk. If you're familiar with it, I think this is a really great, at least aesthetic example of solar punk. Solar punk is when nature and technology really work together. I hope we're all kind of working towards this. Funny enough, this is from a Chobani yogurt commercial. But the artist, I think, is pretty radical, I guess, in this like idea of what the future could be. So there are tons of examples here of using AI and robots to create the world that we want, that is, human-centered, earth-centered, and saves us from damaging labor, and robots and technology can take care of things so that we can be more human and enjoy our community, our land more. But there's also other things to consider ethically, right? And like I was saying with Europe and the AI Act, it outlines a pretty good template of what to consider when using AI. Again, it's like, why are we talking about this? Like, today, theoretically, we're talking about AI in general because it's super powerful, and like I was saying, with great power comes great responsibility. And as we use these tools, we are shaping our values. We are shaping the AI to have our values. And so, for example, transparency. This is super important in a lot of these AI acts, because we need to have trust and accountability, and especially when it comes to like healthcare, of course. But design and world building is, very important in that sense, that there's some sort of security and safety. But also, as we use AI and build models for our own projects, we want to make sure that we can explain how it works. That's why I go into the mechanics just a bit, at least, so that you can have a little bit of the language and framework for being able to explain how it works. This is one of the issues with AI at the moment, is that we have a black box challenge, where you have the input, all the data, and it shoots out an output that's amazing, but we're not really sure how it got there because there's all of these hidden layers, and it's really hard to explain. So a lot of data science or computer scientists right now are working very hard to create interpretable or explainable AI, so that we can have more trust in it and put more faith on it. But like we spoke about earlier with biases, there are tons of algorithmic biases because it's programmed and trained on older data and unreliable data. Like Google uses Reddit, for example, for a lot of their data for their AI model, or ChatGPT using the general internet. But yeah, so a lot of this is mathematical as well. So for example, an example would be like Amazon used an AI for years to hire on people, and it was based off of the data that they had, which was outdated, right? And biased, and also that if they were basing it off of their model, which was who they had in their facilities at the moment, or in the past, and what their skills are correlated with. So even if it, during the hiring process, if it caught that, the word woman or something was in it, the person was like disqualified because it just wasn't probable based off of their data that this would be a hireable person. So how do we deal with that, right? Is it as simple as coding? Can I say, if evil true, then don't? It's not that simple, right? For so many deep philosophical reasons, because who says what is true and not true, what is evil, and like who gets to dictate, right? What is fairness really? When there's so much context to consider. I will have to speed through this, but we spoke about reinforcement learning earlier, and this is that reward system I was talking about. I could neutralize man and woman in this case with Amazon so that they had an equal chance and that gender wouldn't be a determining factor. And that could be one solution. But it is, of course, a lot more complex than that. But what is true would be that you need diversity in the data, not just the people. There needs to be diverse data. It can't just be from all like one source. And it's kind of like you write a paper, you do some research. You don't want all of your research to be from one designer, one person, one institution. You want to diversify it so that you can have a more thorough understanding of what's going on. So if in doubt, just diversify your resources, your sources. And then, I'm going through a lot of these like more complex ethical ideas, but I'll go through it as quick as I can. But with copyright laws, we have to ask, what is legal or not? What is copyright written anymore when everything is, when AI models are being trained on just about everything on the internet? What is fair use? How do we make up for our data is constantly being sold? Can we get royalties on it? Things like that. And then my advice, because everything we do on the internet is for the most part being used to train AI models, to stay relevant or successful in the age of AI, let me say this really quick. My suggestion is don't be scalable. If you can be replaced by a robot, maybe think about that. We've tried for so long to be robotic, and that was very a good merit to be able to produce the same thing over and over and deliver the same results or better. But now AI can do that. If it can emulate that, and if you can, then it can be outsourced to AI. So my point is, as designers, you want to have your unique stance on design. It's, I think, a time to be even more bold with our designs and not be mediocre, because mediocre is going to get replaced by AI. And there will be much more novelty for artistic or creative expressions that are unique, that are personalized, that are a culmination of the human experience. So I put a bit about Starchitects. We know Starchitects as like famous people like Zaha Hadid and Frank Gehry and so on. But I believe in the age of AI, as we have more and more buildings generated by them, that there's going to be a serious interest and requirement for Starchitects on a local level It's no longer just the global architects, but the city architect, I would say, like someone in your town that is known for their take on architecture or their take on design or whatever it is, that we're going to need architects to culminate public interest and get investment for projects. So, yeah, it's a bit like the influencer now, right? There's going to be more of that for creatives and like really being unique and not being repeatable or scalable. But of course, we want to use AI to our advantage as well to take care of the mediocre aspects of our work and to also help us create something new, but that is absolutely because we are the interesting data, the new data that it is powered on. I put this quote by this philosopher here in Portugal, Agostinho de Silva, where he said, "A man is not born to work, but to create, to be that free poet." And as we have AI take on more of our mediocre work, we really want to ask, like, what is the work we want to do? A big thing here is to contemplate is universal income. If AI can do a lot of our tasks powered by us, then we can do so much more. You probably know, working with AI to some capacity at this point, that you can produce a lot more, a lot quicker. And so imagine if you were able to do your weekly amount of work in just a few days, in just a few hours each day, the same amount of work, if not better, and you got paid the same, you know what I mean? Then what do you do with the rest of that time? I innately believe we want to create. It's in us. You can see it in babies. I always joke about the hardest worker on a Sunday is at the beach, these babies with their shovel and pail. They love to work and it's creative and it's fun. And it's beautiful. It's a beautiful thing about humans and all living things is that we want to create. And I think that is very natural and innate. And right now we're kind of working our way out of a weird paradox we found ourselves in of forced work. And so as AI can kind of take on some of that less human work, yeah, how will this change the landscape? And so one of my questions I was hoping we could talk about is, if money were not an issue, what types of worlds would you create or projects would you delve into? And I think this is important to get a head start thinking about this as things become more automated. And also people will be more interested in these types of projects as automation becomes kind of, it dies into the background. Oh, well, so yeah, so I was ending with a quote from Buckminster Fuller, from actually an Instagram post I just did. We are called to be the architects of the future, not its victims. And so I really want to explore the idea that future designers should be visionaries and not just problem solvers, because, yeah, for obvious reasons. So, okay, I didn't do too bad, 12 minutes over. You can find my information there. If you didn't get my newsletter, you can scan that and I will send you all of the information and resources. Tomorrow we'll go over all of the practical tools, from AI generation images to 3D, to using virtual reality. We're actually exploring virtual reality using our smartphones, so not needing the headset, the Oculus of Apple or whatever, but just being able to use your phone to immerse yourself. I think we all have phones, and so this is a very accessible way to enhance your designs and be able to display them. One way to view through your phone is through a cardboard viewer, which I sent in the email, a link explaining how you could build one out of cardboard. And there's a cutout there as well. But it looks put together a bit like this. Sorry, it keeps erasing my background, so, but it had, there we go. So looks like this, has a little peak finder. I have the little lenses. You could get creative with the lenses and just cut, you know, a plastic bottle on the curve. You just want to create that curve, to create that distortion we were talking about. And your phone just slides in the front like so. And then you can close this, and then you can view it. And then we use certain apps on the phone to be able to get that virtual reality effect. And yeah, I'll show you a bunch of tools. We'll go through some workflows, but it won't be until day 3 that we put a full project together. And if you have any questions or anything, please let me know. I will check out your questions. Yes, so in practice, so someone asked about designing through virtual reality and mixed reality. Yeah, so we will explore the tools we'll explore tomorrow. We'll have those technologies. The one art you asked about Archeo, the one Archeo is actually through the Oculus in the metaverse. So we won't be going into the metaverse or using the Oculus for this one, since I wanted this to be more accessible and kind of like a beginner introduction to virtual reality if you don't have a headset. So for tomorrow, I think tomorrow it'll be quite a bit of watching me use the different tools. So you don't necessarily need to download the apps yet, but I'll show you so many different apps and you get to decide which ones you like, and then you can download them. I'll make sure to add a QR code to each of the slides or something like that. I'll create a way so that you can download them as we're talking about it, if you like it, because there's so many different tools. You don't probably want to start an account or download all of them. This is really about like getting an overview and seeing what you like and what you want to explore more and going from there. If you wanted to go for it, you can do the VR headset. There's that cutout. You print the cutout, you put it on the cardboard, cut it out, and then it's a matter of improvising with the glass lens. Everything else you can do without. And by everything else, I just mean I have like a little magnet here. So when I push this guy, it tapped my smartphone screen. So if I wanted to change like worlds, or if I wanted to play a game or click on something, I could do it from here, which is pretty cool. But you can always just take it out manually, change it, and then put it back in. That's about it. So tomorrow you'll be seeing a bunch of different tools. You'll get to download the ones that you like. And then on day 3, it would be cool if you had all of those apps downloaded and everything ready, and then we can create together. Yeah, I think that's about it. So, if you have any other questions, you can email me, you can message me on all of the socials. Feel free, and I will answer them. I'll try to answer them promptly. Thank you so much for attending day one. I know that was a lot on, like the ethics and the abstracts of AI. And I know you guys want to probably just like design and stuff, but I think it's really important to take that breath and like kind of see what's going on. What's the landscape? How is it working in general, before engaging with it? So you have a more informed and like responsible way of using these tools. Okay. I will see you guys tomorrow. Thank you so much. Have a great day. Ciao. Thank you so much.